Today, we are digging into an absolutely incredible engineering story that goes all the way back to 1898. See, San Francisco's most iconic landmark is sitting on ground that literally behaves like liquid during an earthquake. So how does it stay standing? Well, we're about to uncover the secret that keeps it from sinking. So let's just ask the obvious question. How on earth do you build a 75,000-ton tower on top of what is essentially liquid ground? And get this isn't just some old-timey curiosity. The solution they came up with over 100 years ago is still the principle holding up some of the world's tallest structures today. To really appreciate the genius of what they did, you first have to understand the sheer scale of the problem they were facing. We're talking about building conditions that would give any modern engineer a complete nightmare. Okay, so picture this. It's the 1890s and San Francisco is just exploding thanks to the gold rush. The city is bursting at the seams. It needs a grand gateway, a huge new ferry building. But the only spot to build it was prime waterfront, which, not long before, had actually been underwater. They were literally building on land they had reclaimed from the bay. And we're not talking about a small building here. The plan was for an absolute behemoth, weighing in at 75,000 tons. That is a staggering amount of weight to put on any ground, let alone ground that's basically unstable. So all of that immense weight had to sit on top of 55 meters of something they call bay mud. Now, this isn't just soft dirt. It's a kind of semi-fluid sludge, and here's the kicker. In a place like San Francisco, when an earthquake hits, that mud can liquefy. It temporarily acts like a fluid, losing all its strength. It just turns to soup. You know, in a seismic zone, trying to build on top of something that can turn to liquid at any moment, well, that's a builder's worst nightmare. It was a genuine recipe for disaster. Any traditional foundation would just sink or completely collapse. They needed an idea that was totally out of the box. So in comes the hero of our story, an engineer named Howard Holmes. He knew a conventional approach was absolutely doomed. So he turned to an idea that was, at its heart, beautifully simple. It was inspired by something you could try yourself with just a handful of nails and some wet sand. So check this out. This is his whole logic right here. If you stick just a few piles or nails into wet sand, you can wiggle them around pretty easily, right? They're unstable. But if you pack a ton of them together, really close, the entire cluster becomes incredibly rigid and stable. It's not about how deep one nail goes. It's about the collective strength of the whole group. So, Holmes decided to take this simple nails in sand idea and scale it up, way, way up. The plan was to create a massive, hidden forest of timber right there under the bay, a foundation that would grip the mud itself instead of trying to push through it to find something solid. And believe me, this was a massive undertaking. Workers started driving thousands upon thousands of wooden piles into that sludge. When all was said and done, they had hammered in more than 5,000 Douglas fir piles, each one about 80 feet long. They created this dense, man-made forest deep inside the bay mud. Now, here's the absolute secret sauce to the whole thing. The goal wasn't to hit solid bedrock way down deep. Nope. The real magic was in maximizing what engineers call skin friction. By driving in so many piles, they created an enormous amount of surface area. And it was the cumulative grip of the mud against the sides of all 5,000 of those piles that created this unbelievably powerful and rigid foundation. So what you end up with is this incredibly strong, 3-layer cake of a foundation. At the bottom, you have the clusters of wooden piles gripping the mud. Sitting on top of those were 111 big concrete piers, and then connecting everything together was a huge reinforced concrete mat under the entire building, spreading the weight out perfectly. The building was basically floating on a giant block of mud that had been locked into a solid mass by this underground forest. Okay, so building the tower was one thing. It looks great, but the real test, the ultimate proof for this radical idea, wasn't going to come from the building's own weight. It was going to come from the violent shaking of the earth itself in one of the most active earthquake zones in America. And prove itself it did. Big time. Just 8 years after it was finished, the catastrophic 1906 San Francisco earthquake hit, leveling huge parts of the city. But the Ferry Building, it stood strong. Then, fast forward to 1989. The Loma Prieta earthquake causes massive damage all over the Bay Area. And again, the Ferry Building survived. It was the ultimate testament to Howard Holmes's brilliant idea. And what is so cool is that Holmes's idea from the 1800s didn't just fade into the history books. It's the direct ancestor of the foundations for modern marvels. Take the Tokyo Skytree, the world's tallest freestanding tower. It's also built on soft, former base soil. And its foundation uses concrete piles with these special knuckles designed to maximize, you guessed it, skin friction. So the big takeaway here is actually pretty profound. Stability isn't always about digging down until you hit solid rock. Sometimes it's about using the grip of the ground itself to turn that site's biggest weakness, the liquid mud, into a fortress. And that really leaves you wondering, right? As our cities push skyward, growing taller on land that's more and more challenging to build on, what other century-old secrets are just sitting there, waiting in the archives to be rediscovered and solve the problems of tomorrow?